Okay, so now we come to take a look on some examples how we add and subtract the factors as follow. So you bear in mind that factor is like from point to point. So for example, even you don't have a diagram which is provided on the right, from A to M to D, so that's why it's AD factor. So if you look at the figure on the right hand side, so it's A to M, M to D, so that's why the outcome would be AD factor. So hopefully it helps you to understand something. So similarly, we jump to part C first. It's from A to B, B to C, C to D. So at last it's AD factor as well. So you see A and C are totally different additions, but at last they are still talking about moving from point A to point D, moving from point A to point D. So the only thing or the only skill you have to manage will be talking about B and D, where you have minus factor in the question. And then so how we deal with it will be using the idea we mentioned right now. So for example, like minus CD factor itself, that means it's plus DC factor. So you can interchange the position of the vector, and at last you will see that it's moving from E to D, D then to C. So that's why the answer will be EC factor. Similarly in part D, EA factor, well enough, plus AC factor, okay. Next, the only job you have to change will be you change to plus CD factor. So that's why when you read the points carefully, from E to A to C, C to D, so that's why coming up the answer will be ED factor. So hopefully it's not very difficult to you. And the next part will be is talking about kind of like equal vectors. So you have a very terrible thing like P vector in terms of A and B, Q vector in terms of A and B as well. And so there are so many letters, so that's why you have to distinguish the difference between, for example, Mn they are scalar. For example, it's like 2, it's like 3, for example. While AB factor is talking about factors, they are talking about direction. And now the key point would be you're talking about PQ factors, they are identical. And then you have to find M and N out. And then, so what's the meaning of equal vector? In this case, will be, it's like comparison. And then, so what's my meaning is, so when you compare the A vector and A vector, and also B vector and B vector, so then you can set up two equations to solve it. So the first one would be you've got 3m plus 1. So we don't write A vector, and it's better to just look at the number. And then, so that's why m itself, so it's minus 1. And then similarly, you have 5 is equal to n minus 1. And then, so n is 6. So I just mentioned it's not good, so it's definitely not recommend to talk about like 3m plus 1 A vector is equal to minus 2 A vector, because next step you are still going back to 3m plus 1 is equal to minus 2. But so to this presentation, it's very easy to give you a wrong concept saying that the A vector is cancelled, and it's definitely not. So that's why I don't recommend you to use this presentation, but you just take out the constant or the scalars directly from it. So I just mentioned the word scalar because so in vector form, normally we use scalar instead of constant or coefficients that some words you have used in before. Next is a harder question about vector because you are seeing a question talking about proof. And then so let's take a look on it. And then so the question is about Mn vector. So I mark it as red arrow. While you have talking about AB vector, DC vector, so AB vector also pointing down, and also DC vector also pointing down. So it's very hard, or you have no idea to talk about it because so the three vectors, they're pointing in 3 different directions. They seems to be totally unrelated. So that's why how we start the question would be I would be thinking like if you want to discuss about Mn vector, it's like from M to N. So it seems like in the picture there are 2 paths. One is in this direction, and then the other one I put in blue, so it's in this direction. So how about we figure it out to see what's happening afterward? Just try and error, you remember, so it's always a very powerful tool in math or in M2. Mn vector can be written as Ma vector, plus AB vector and plus BM vector. So it seems to be no use, but yet you can see AB vector pop up in my answer. And then similarly, so we can also have like MM vector equal to MD, and then DC, and finally CM vector. So again, so it's a bit good to have DC vector here, because DC vector is something we want. But how can I combine them together? Now I try to read the question again, and I find that I overlook a point called MN are midpoints of AD and BC respectively. Midpoint itself, what can you think about them? Yes, so you can talk about equal length. And in vector sense, you can also talk about MA vector, MD vector, so they are equal in length but opposite in direction, which means they cancel each other. Similarly, BM vector, CM vector, so they are equal in length, opposite in direction, so that's why they can cancel each other as well. So that's why the trick on the question would be you have to see whether you see the relations between MA and MD vector, and also BM vector and CM vector. So if you can observe it, you will see that MD vector, it can be written as minus of MA vector, while CM vector can be presented as minus BM vector. And of course, we still have DC in between. And now, can you read equation and equation 2 carefully and see now how you can obtain the answer? Well then, you will see that now when we have 1 plus 2, so indeed it's talking about MN vector at itself, so we have a double. And now, so it's something very good because, okay, MA vector minus MA vector is gone. BN vector minus BN vector is gone. And coming up, you have only AB vector and also DC vector left in the expression, and it comes to the result. So later on, so we have just 2 examples to illustrate the ideas, but of course, do remember, so I will mark some questions for you to try and to consolidate your idea about vectors.